Method of undetermined coefficient. So in this video we are going to learn how we will use the method of undetermined coefficient in order to find the particular integral. First step, we need to find the trial form of a particular integral, and after that with that form we can find what is the exactly particular integral of that question. The concept of method of undetermined coefficient is divided into two parts. In this video, we will just learn how to write trial solution of a particular integral. And in the next video, we learn how to find the particular integral with the help of this trial form. First case, if the non-homogeneous function in a differential equation is of the form e raised to power ax, in that case we assume that particular integral is of the form some constant into the same term. So whatever the term we have in this case, same term we will take it as it is, but we will take some constant over here. Second case is if we have sine ax or cos ax, or maybe the combination of these two with some multiples. In that case, we assume the particular integral is of this form where a0 and a1 are the constants and sine a of x, that is the same angle whatever the angle is mentioned over here. And this case, make sure the angles are same. Only in this case we will write the answer in this form. Next case is a polynomial. So whenever we have a polynomial of degree m, so this is the polynomial of degree m, but it contains further terms, but the degree of this polynomial is m. Same in this case, it contains more than one term, but the degree of this polynomial is m. So in that case, the particular integral is written in form of a polynomial with the degree m. Means we need to take each and every term of the general polynomial of degree m along with the coefficient. So here may be some coefficient a0, and in this case some coefficient a1, here a2, and last is am minus 1, and make sure there is a constant term as well, that is am. For example, if we have the non-homogeneous function of the form x cube, in this case the particular integral is written in the form of a0 into x cube plus a1 into x square plus a2 into x plus constant term, that is a3. Moreover, we have these two cases. In the first case, if it is an exponential into sine or exponential into cos, or maybe exponential into cos plus sine. In such cases, the trial form of a particular integral is of the form exponential, sine as well as a cos, but we will write the constant over here. Next is if we have exponential into polynomial. In this case, if we have only exponential term, we are writing the answer into a into e raised to power ax, where a is any constant. For x raised to power m, we are writing the polynomial with the degree m with certain constant over here. Now, rather than taking a different constant, we will just take this constant inside rather than writing over here. Now, new constant is a0, a1, am minus 1, and last is the constant am. So in this case, the particular integral is written in this form. Do not attach the constants over here. So whenever we are writing a particular integral form, we need to follow this note. It says that if any term of the trial form of particular integral appears in a complementary function, in that case we need to multiply the trial term by x raised to power m, where m represents the multiplicity of the term, means how many times that term is repeating. Let's understand this with the help of example. Question is, using the method of undetermined coefficient, find the particular integral for the following differential equation. So starting with the first case, in this case the non-homogeneous function is of the two type and three different terms are there, exponential and sine, and the terms are e raised to power minus 2x, e raised to power 2x and sine x. So according to this, the particular integral is of the form some constant times of same factor e raised to power minus 2x plus, for this one, some another constant. So we can separate this constant values. Maybe it is a b times of e raised to power 2x plus c times of. So whenever we have a sign, in that case we have cos as well. So we will write it as sine x plus some constant into cos of x. So this is the particular form by observing this non-homogeneous function. Now we need to recall that important point. So according to the important point, we need to calculate the complementary function. So for complementary function, we need the homogeneous differential equation and we will convert this into the operator form. So operator form of this differential equation is this. Now collect the coefficient of y, then write the auxiliary equation. We have this auxiliary equation. Then after that we will find the roots. So roots in this case is minus 2 and minus 2. Now what is a complementary solution in this case? Whenever the roots are repeating, in that case the solution is written in this form. For more details on a complementary function, the link is given in the description. Now, the important point is if any term from this trial solution. So now in the trial solution, we have a four terms, e raised to power minus 2x, e raised to power 2x, sine and cos. Now, whether sine and cos are the part of complementary function? No. So it means we will not multiply by x over here. Now e raised to power 2x, is this is a part of a complementary solution? No. So it means again we will not multiply by x in this case. Now for the first case, e raised to power minus 2x. So how many times it is repeating? Or you can observe this factor minus 2. Means if the auxiliary equation has a root minus 2, it has a root as a minus 2. How many times? That is a 2 times. So we multiply this term by the x square. Hence we have the final particular integral form by using the method of undetermined coefficient. So let's taking the another example. In this case, particular integral is of the form. So we have sine x and cos 3x. Both the terms are different because the angles are different. For sine x, answer is in form of sine and cos. So we can write this is a naught sine of x plus a1 cos of x. Now, for cos 3x, we have b naught cos of 3x plus b1 sine of 3x, because whenever we have a single terms as a sine or a cos and their angles are different, in that case we need to take the alternative term with that. If it has a sine, then we will take cos as well. If it is a cos, we will take sine as well. For polynomial, we need to take the polynomial of degree 2. So we can write it as c naught x square plus c1x plus c2. Now we need to check whether we need to multiply by x with any of the term. For that, find the complementary function. Complementary function is evaluated for the homogeneous equation. Right at operator form we have this. Now collect the coefficient of y, we have d square plus 1 into y is equal to 0. Auxiliary equation is m square plus 1 is equal to 0, and the roots of m are plus minus iota. So in the case of complex, complementary solution is equal to e raised to power 0x, that is a real part, into first constant cos of x plus second constant sine of x. So make sure these constant and this constant are different. So you can write with some another constant as a small c1 and this is a small c2. Now observe the particular integral. In particular integral, from here whether any term appears in a complementary solution. No. So there is no need to multiply by x. Now for this one, cos 3x or a sin 3x, is that is a part of a complementary solution? No, because the angle is different. In this case, it is a 3x and it has x. So it means both the terms are different and there is no need to multiply by x over here. Now what about this one? Sin x is a part of a complementary solution. How many times? One times. Cos x is a part of a solution. How many times? Again one times. So we multiply this entire term with x. And this is the final particular integral form by using an undetermined coefficient in this case. Let's answer this question. So in this case, we have exponential into sine. So in that case, exponential case, particular integral is of the form a times of e raised to power 5x, and whereas for the sine, it is kind of b times of sine 2x plus c times of cos 2x. Next, we can multiply a with both the terms. So we have simplified form e raised to power 5x, a into b, we are taking it as a naught. So I am writing a naught into sine 2x plus a into c, let it be a a1. So this is a1 cos of 2x. So we can directly write the particular solution form from here as this. Now we need to check whether we need to multiply by x or not. So in this case, operator form is d square minus 6d plus 9 into y is equal to 0 because we need to find the complementary solution. For that, we are taking a homogeneous equation. So write the auxiliary equation. Auxiliary equation is m square minus 6m plus 9 is equal to 0. And roots in this case is 3 and 3. Again repeated roots. So complementary solution in this case is c1 e raised to power 3x plus c2 x times of e raised to power 3x. In this case, we have two different terms. One is e raised to power 5x into sine of 2x, and the second term is e raised to power 5x cos of 2x. Now whether they are the part of complementary solution? No. So it means there is no need to multiply by x in this case, and hence this is the final integral form for this case using the undetermined coefficient. So in the next example, we have changed the right hand side function, although the complementary function will be same. So same question is here. So complementary solution in this case is c1 e raised to power 3x plus c2 x e raised to power 3x. Particular integral for this one, we can directly write that is equal to e raised to power 3x into a times of sine 2x plus some constant b times of cos 2x. Now we have these terms are entirely different from this one because in this case we have two terms as e raised to power 3x into sine 2x, and the second term is e raised to power 3x into cos 2x. So do not understand that this e raised to power 3x is repeating over here. They are the entirely different terms. So therefore there is no need to multiply by x for this trial solution of particular integral. Next question is this, in which we need to find the particular integral form by using undetermined coefficient for these three different values of Rx. First, we will evaluate the complementary solution. For complementary solution, we can write its operator form, and after that we can write its auxiliary equation, that is equal to this. Then you can find the roots of this one. So for this we have two roots, that is -2 and -2. Both the roots are real and equal. So therefore this complementary function is equal to c1 e raised to power minus 2x plus c2x into e raised to power minus 2x. Now for the first case, if your right hand side non-homogeneous function is e raised to power minus 2x. So in this case, the trial form of particular integral is equal to, this is a times of e raised to power minus 2x. And if the Rx function is of this form, so in this case, the particular integral form is, this is e raised to power minus 2x. Since we have a polynomial, so we write linear polynomial, that is ax plus b. And for the third case, the trial solution is, exponential term is as it is, and for x square, the trial solution is a quadratic equation, ax square plus bx plus c. Now we can observe that in all these three cases, it has a factor e raised to power minus 2x. Whether e raised to power minus 2x is a part of a complementary function. So yes, how many times? That is 2. So in this case, we multiply by x square. Same over here, we need to just observe the exponential term. So this exponential term is the part of complementary function. Yes, how many times? 2 times. So again multiply by x square. Similarly, for this case, observe for this term exponential. Is this is appearing in the complementary function? Yes, that is 2 times. So we multiply this trial solution by x square. So this is the final particular integral form for these three different cases. Let's answer the next case. We need to find the trial solution of a particular integral. For this case, in this case, we have the non-homogeneous function as a polynomial. Now we can observe that the maximum power of x in this case is 2. So it means the particular integral in this case is of the form of quadratic equation, that is x square, x term, and there is a constant. So we will attach some constant over here, a times of x square plus b times of x plus some constant. Now the point is whether we need to multiply by x. So for that we need to write the complementary solution. We are writing the operator form over here. This implies the coefficient of y is equal to this. Now write the auxiliary equation, replace d by m and y by 1. After that find the root. So roots are real and they are different. According to this, the complementary function is equal to first constant e raised to power 5x plus second constant e raised to power minus 2x. Now observe that whether x square or x or any constant term is available in a complementary function. So no. So there is no need to multiply by x, and that is the final particular integral form for this case. Next case, we have three different terms. So according to this, the particular integral is of the form some constant e raised to power x plus some constant e raised to power 3x plus some constant e raised to power minus 2x. Do not take 12 over here because that is automatically get adjusted with this constant. Now find the complementary solution, whether we need to multiply any term with x or not. For that, write the operator form, then write the auxiliary equation, The roots in this case is minus 2 and minus 2. So in this case, the complementary solution is equal to C1 e raised to power minus 2x plus C2 e raised to power minus 2x into x, because both the roots are repeating one. Now e raised to power minus 2x is appearing 2 times in a complementary function. Therefore, we will multiply by x square in this case. Whether we need to multiply by x over here, so it is e raised to power 3x, and that term is not repeating in a complementary solution. So there is no need to multiply by x. So this term is as it is. What about this one, e raised to power x? Whether this is the part of a complementary solution? No. So there is no need to multiply by x over here. So this is as it is. In the next case, again we have an exponential form. So in this case, the particular integral is of the form some constant e raised to power minus 3x plus some constant e raised to power x. Now we need to multiply by x or a not. For that, we need to write its complementary solution. So its operator form is this. Collect the coefficient of y, we have this term. Then write the auxiliary equation, that will be m square plus 6m plus 8 is equal to 0. And in this case, the roots are minus 2 and 4. So finally, complementary solution in this case is some constant e raised to power minus 2x plus C2 e raised to power 4x. Observe the particular trial solution. It has a term e raised to power minus 3x and it is not the part of a complementary function. And same for e raised to power x, it is not the part of this complementary function. So therefore, we will not multiply by x in this case, and this is the final form of trial form of particular integral. Okay. Taking next example, in this case, on the right hand side function, we have sine and cos, but their angles are same. So whenever the angles are same and they are in a combination form, solution is in form of sine and cos with the same angle, that is some constant into cos of x plus some constant into sine of x. Now we need to check whether we need to multiply by x or not. So for that, write its complementary function, write its operator form, that is equal to this. Collect the coefficient of y, we have this term. Then write its auxiliary equation, replace d by m. After that you will get this form, and the roots in this case is equal to this one. So this is a complex root. In this case, the complementary solution is equal to e raised to power real part. So we can split this term as minus 3 by 2 plus minus under root 39 by 2 into iota. So the real part in this case is minus 3 by 2 into x. First constant C1, cos of imaginary part, that is root 39 by 2 into x plus second constant sine of root 39 by 2 into x. Now, is cos x or sin x is a part of a complementary solution? No, so there is no need to multiply by x in this case. Taking next example, so in this case, the particular integral is of the form sine 4x, single term is there, so answer in form of its combination of sine and cos. So we can write it as a times of sine 4x plus b times of cos of 4x. Next, need to check whether it is getting multiplied by x or x square. So for that, write its complementary solution. So write its operator form, that is equal to d square into y plus 16y is equal to 0. Now collect the coefficient of y. So we have this form. So auxiliary equation in this case is equal to m square plus 16 is equal to 0. Roots are plus minus 4 iota. So in this case, the complementary solution is equal to real part is 0, e raised to power 0x, C1 cos of 4x plus C2 sine of 4x. So e raised to power 0x is 1. So we can write this form as it is. observe the particular integral. So in this case, we have sine 4x and cos 4x, and both the terms are the part of the complementary solution. So therefore, we will multiply this trial solution by x. Okay. So next we have this question. So in this case, first we will write its complementary solution. So start writing with the operator form. The operator form is equal to this. Then collect the coefficient of y. We have this one. Then write its auxiliary equation. Auxiliary equation means replace d by m and y is 1. So we have this form. Now we need to find the roots. One procedure is hit and trial. After that, we can find the synthetic division method to get the quadratic equation, and then we can find the root. Second, we can observe that in this case, we can collect the coefficient of m square. Then their term is m minus 1 plus, take 1 outside, we have m minus 1. So finally, we have this form, and from here we have three root, one from this side, that is equal to 1, and from here we have root as plus minus iota. So in this case, the complementary solution is equal to c1 e raised to power x plus, for this one we need to write the answer in form of exponential cos and sine. So real part in this case is 0, that is e raised to power 0x into another constant cos of imaginary part, that is 1 into x plus c3 sine of imaginary part into x. E raised to power 0x is 1, so simplified form is first constant e raised to power x plus c2 cos of x plus c3 sine of x. Now observe the non-homogeneous function, that is the 6 times of cos 2x. So in this case, the particular integral is of the form some constant. Since it is a cos term, so answer will be in terms of cos as well as sine. And make sure the angle is same 2x and 2x over here. Now whether this is a part of a complementary solution? No. So there is no need to multiply by x in this case, and this is the final trial form of the particular integral for this case. In the next video, I will explain how to find these constants a and b.